Hello and welcome to Module 4. Today we will look at the SPEEDIER service and the energy pyramid. Now just some quick definitions in the SPEEDIER service. First we have the SPEEDIER expert. This is the relevant energy auditor or public body representative that has undergone SPEEDIER training, SPEEDIER expert training that is. And then the SPEEDIER champion, which is the representative in the SME that helps educate and use awareness techniques to motivate the team around them and to bring about an energy culture within the SME. Moving on, we're just going to compare the ISO 50002 versus the SPEEDIER service. Now, there are three types of ISO audits. Type 1, which is the minimum level of detail, and Type 3, which is the maximum level of detail. Typically, 1 is only used for SMEs as it looks at low cost measures and is a high level review of consumption. Funding options, metering options, or energy balances are not covered in Type 1 as it is not cost effective. It just shows that SMEs are only seen as a high level review rather than an in-depth look at the SME and how it works and where to save money. From the implementation point onwards in the SPEEDIER service is a new improvement on the ISO 50002. So we'll go into more detail into SPEEDIER service. The steps involved are step 1, engagement. Engagement is the SPEEDIER expert contacting SMEs directly to advertise the SPEEDIER service and advertise the implementation stage past the ISO 50002 and introduce this idea of a ring fencing mechanism and the savings from it, which is your no cost leads to your low, your mid and your high costs. Introduce the concept of a stage energy assessment process. Instead of getting all the details in the first day, it's good to kind of pick up the idea and focus your efforts on one ECM. From that, you can use real-time data to implement more changes throughout the site. And the most important thing is obtain commitment from senior staff at this stage. If you obtain commitment at this stage, it's very easy then to roll out the other steps. And if you don't get commitment, it's very hard. The SPEEDIER expert provides SMEs with a quotation for initial site visits as well. Step 2 is identification or identify. Prior to the site visit, the SME will send all energy related bills to the SPEEDIER expert. And typically a 1-day visit of the SPEEDIER expert will take place. And this will, on the day of the visit, the SME makes key person available. So the SPEEDIER champion usually, the person in contact with the SPEEDIER expert at all times. And this all comes together for baselining of the energy consumption in accordance with best practice for energy assessment, which is ISO 50001. And then after all is said and done, they have to decide on the next step of the SPEEDIER process. But is it a good idea to go with ECMs that are identified, or is there other areas that have more scope? It's all about communication between the expert, the senior staff, and the SPEEDIER champion as well. And as required, the SPEEDIER expert will provide assistance regarding the assessing of finance or government supports. Step 3 then is implementation or implement. The expert and SME organise training or ECM implementation on site, whether it be contacting suppliers or another on-site visit to gather more data and to implement the actual changes on site. So the expert will provide advice on the savings and monitoring of savings. Monitoring is very important, as without you cannot verify what you've done unless you have monitoring on a specific ECM. Like if you changed out a compressor, or if you did a compressor leak test, you wouldn't know how much you saved unless you had a meter on that specific compressor. On conclusion of this phase, there will be a complete report on the implementation and ECM implementation sheet. The measured savings and the commitment to reinvest the savings will also be a part of this stage. And this stage is not considered in ISO 50002. Step 4 is review. So this is a simple step where The expert meets with decision makers and reviews the savings that have been calculated from the data received and plan up the next steps, especially in the ring fencing mechanism. With low cost and no cost ECMs, it's very hard to quantify how much savings have been made. But when those quantifications come together, you can see that there's a lot. So basically, this stage is just reviewing the funding that's available for the next stage of the project, the next ECM of the ring fencing mechanism. And again, the expert will provide a quotation for involvement in the next step. And then step 5 is just repeating the whole process over and over again. This will help with keeping up the ring fencing mechanism, and before each implementation or review cycle, the expert provides a quotation for their input indicating the payment that is required. And now we're going to talk about the energy pyramid. The energy pyramid is a simple concept. There's 3 tiers in this pyramid, and it relates to the ECMs that you will see in this peer project. Energy conservation is the first step at the bottom there, followed by energy efficiency second, and renewable energy. It's basically showing you that the low cost and no cost in energy conservation, which is turning off lights, reducing window glare, turning down temperatures, reducing leaks. These small changes, they don't have to be colossal changes like installing a huge PV array. These small changes can add up over time and actually save you more money than you'd expect. Energy efficiency then is replacing equipment like it says there, replacing refrigerators, replacing household items like a washing machine there, or light bulbs and things like that. This is the stage where you upgrade what's already there. And then your renewable energy. Renewable energy is then a new step that you should be bringing, our new technology you'll be bringing to site. It's like solar power, wind power, biomass power, whatever it may be. Here we can see a more complex look at the energy pyramid, with understanding being at the bottom. Understanding is very important, as you need to understand where your energy is being used, and then you can understand where your low and no cost energy savings will come in. Lighting is always an easy one that people jump to straight away, as LEDs have become more efficient, and they're pretty much the first line of attack that people usually go to. Air sealing or air tightness within buildings is another big one. Appliances, insulating and ventilation is big too. Water heating, whether it be a change of boiler or a change of calorifier for your domestic hot water. Heating and cooling, so upgrading your heating system, upgrading your cooling system. Windows and fabric, which is near the top there, as it's a very long payback period, as the structure itself, it's important for air tightness and heating and cooling, yet at the same time the thermal efficiency of it is the problem. But again, with the very long payback period, it's very hard to find any real reason to invest in it. But after all these changes you've done before, you have saved up enough that you can possibly look at this. And renewable energy is at the top. Renewable energy should be your last attack, as you should know how much you're using and how much you can save before you put in a new solar panel or you put in a new wind turbine. As you could, from now, you could say, oh, I could use this amount of energy, but after all your changes, you could use half the amount of energy. And then you have a renewable energy source that's dumping nearly half of what it's making, and again, reducing the cost effectiveness of it. So the first step again of the energy pyramid is energy conservation. And there's a quick little tip that you can think of: the 4 T's of energy conservation, which is turn off, turn down, and trial. Starting with turn off, which this is for lights, computers, machines when not in use, to turn them off. Simple turning off the light switch, it can save you that amount of energy for that period of time. And in 2016, Codema saved €11,000 and 70 tons of carbon a year by implementing a turn-off campaign in a council office in Dublin, by turning off office equipment at the end of each day and lighting equipment. Tune, then, on the other hand, is the time of use of boilers and equipment. So if a 4K motor or a boiler turned off for an hour a day, this could save around 11 or 114 euro a year. Doing the same with a 50 kilowatt motor could save over 1,425. This is 1 hour changes. This could happen for your heating system as well, where you reduce the heating time once a week or once a day by an hour. So you have that at the end of each day, you have that period where people are starting to move, starting to go home, starting to get packed up. If you turn off the heating just an hour before that, then you could look at serious savings. The next T is turn down. So boiler, thermostat, or hot water, lighting, things like this. So you've turned down the amount of hot water that's going into your boiler or coming out of your boiler. Turn down the thermostat your for your heating system, your heating ventilation system, or even turning up the thermostat in a cooling system. Hot water, turn down the set point on the hot water tank to around 60 degrees. Instead of 65, this 5 degrees will save you nearly 10% on every degree. That's one way you can look at it. And reducing the speed of motors and reducing the light levels as well. All this comes together as an energy saving. As it says there, reducing the speed of a motor by just 20% can halve its energy consumption. And reducing by 1 degree in a thermostat can reduce heat costs by 10%. And finally, the last T is trial. So trial an area. So if it's successful, repeat throughout a site. So if you turn down a boiler thermostat from 20 to 19, this can result in 10% energy saving costs. Trial this for a week. And if all staff are happy with it, staff comfort should be at the start of all your, at the forefront of all your problems. If staff are happy with the change, then continue with 19 degrees for the rest of the year. These are all no cost measures. It's all about staff or day-to-day behavior, and they're the main factors to consider, and also the main factors to trial and see if there is content amongst staff. Moving on, then we have energy efficiency. So another way of thinking of it is the 3 R's: renovate, replace, retrofit. So renovate is upgrade your building structure or fabric, which means a fabric upgrade like insulation or air tightness or new windows for air tightness. Replace is replace less efficient or oversized equipment with more efficient equipment like motors, lights, pumps, fans, boilers. These are equipment that maybe could be at the end of their life and they are less efficient than newer models. Or they could be oversized as well. A lot of pumps that were installed long ago, they were installed to have nearly 150% capacity of what they needed, just in case. That just in case isn't good enough anymore. To reduce that down, it reduces your running costs of your site. And then finally, a retrofit, which is upgrade your systems, like your heating system. So changing out pipes and changing out a whole boiler system. You can have a whole heating system change out, more rads, change out ventilation system, change out your air handling unit, new ducts, new plenums, things like that, compressor. You can introduce a new compressor or new compressor line, and water system. So you could replace your new calorifier or replace the calorifier with a newer calorifier with an immersion, for example. That will only be used during the summertime, as there's no need for heating during the summer. And engineering calculations can be used to get an estimate of values, but metering is the real-time data, and it also shows you real-time savings. So metering is very important for all these different ECMs. And finally, on the energy pyramid, we have renewable energy. Here's just a few links to a few websites that are available for the Irish pilot region, which is SEI. They have a lot of resources available for technologies, whether it be solar or CHP or wind turbines, things like that. And if you want more information, then you can look at the Irish Solar Energy Association. They have multiple publications on solar potential in Ireland and the up and coming solar panels that are available in Ireland too. Then you have the Irish Wind Energy Association, which has multiple publications on small scale wind energy and also large scale if needed. So you can see those links there for those websites. So taking an overview of renewable technology, we're going to look at solar panels. So there are two types of solar panels available to the Irish market, which is photovoltaic and thermal solar. So photovoltaic converts sun's radiation, so the sun, into electricity. And thermal is, as it says, it harvests the radiation from the sun and uses it into usable heat. So you can see there the pictures. The top one is a photovoltaic solar array. You might see them on the tops of houses and on roofs of factories and things like that. This is for electricity, and the bottom one there are evacuated tubes, which are mainly used for hot water, or hot water top-ups, as they're called, to help with the hot water system in a house or in a business. And just talking about PV, there's some tools available to help you figure out if your site is actually able for, or is it worthwhile getting PV for your site. So there's things like the SEAI solar PV calculator, which kind of calculates the amount of energy you'll get out of the solar array and the size of the solar array needed for your site. Then you have the Electric Ireland solar PV calculator, same thing as SEAI. You got the European Commission photovoltaic map as well. It shows you throughout Europe the radiation potential that you get. You see there on top right, that's for Ireland. It says photovoltaic power potential. You see down the sunny southeast, like Waterford and Wicklow, is the highest potential, with medium results throughout most of Ireland, except for up north near Sligo, Letterkenny, and Donegal, and Westport and Mayo, should I say. And then there's a solar PV potential and global aerodynamics maps. They're the main things to help you find out if your site is able for, if it's worthwhile for PV, not able for PV. Every site is able for PV. It's just, is it worthwhile and is it cost effective? And it's also good to note that there are some companies that are providing solar panel upgrades for free. They install the solar panels for you, and then you pay less money per month for your electricity than from, you could say, from SSE or any of your electrical suppliers. So these companies come in, install solar PV for you, and then you buy the energy off them. You're basically leasing energy from them. That's one way to look at it. It's just some pros and cons on solar PV and solar thermal. So pros for PV is there's a long lifespan. They're typically around 25, 30 years. They're once they're up there, they're mainly up there for good. You could think of it that way. They work in all climates, as it doesn't really need heat from the sun. It just needs to be in contact with sunlight. And sunlight, of course, is hard to come by sometimes in Ireland, but it's constant really. And they're affordable, but they're about 5,000 to 10,000 for a home. A lot more for, let's say, a larger array for a business with a large roof. But it all depends on how much or how many solar panels you want to include. It increases the property value is another big one, where if you are selling your property after end of your business or things like that, or if you've unfortunately come to terms and you have to close down, if you sell your business with PV on, it's actually more valuable for the market. It's a renewable source of electricity, and operating and maintenance costs are very low. They rarely break down. The only thing that breaks down usually is the connectors from the inverter from the PV array into your supply. That's really the only place for error. Or if there's a large storm and they get damaged, that's the only thing really. And no noise pollution is a big one. With wind energy, I'm sure if you've ever drove past a wind farm, you could hear them from nearly a mile away. With solar PV, there's none of that. Some cons, some fairly easy ones to think of. If they don't work at nighttime, there's no sun, there's no energy, that kind of a way. They are seen as indiscreet or an eyesore sometimes, with very large amounts of them being seen as, well, yeah, indiscreet. That's preference more than anything. They cannot provide 100% electricity needed. This is only if the size of your roof is, it's usually around 50% they can provide for most places. Even with homes, they can provide nearly up to 100. But for large companies or SMEs, it's very rare that they will get 100% electricity required. It would mainly be 50% load, as if you have 100% all the time, if you close down for a week, all that energy is going to be wasted, and the cost effectiveness of your solar PV array is going to drop to the floor. And there's no way to sell to the grid as of yet in Ireland. Now, there is a scheme for smart meters being brought out with the ESB, and they're looking at microgeneration for certain businesses to sell back to the grid and reduce their own costs. They're fragile. They are fragile. If anything like a tree branch or anything hits one of the PV panels, they will shatter and they will break in half, more than likely. For large arrays, battery storage must be implemented. This is to stop as difficulties with asynchronicity. So if you're not using enough energy and your energy is being created more and more on the top and on your solar panels, you need a battery storage system. Well, it's optional. You could just throw it away back to the grid for nothing. But if you want to make it more cost effective, a battery storage system implemented alongside it will hold that electricity for you when you don't need it, and then when you need it, it'll be there. And it's not applicable for everyone. It depends on your site, if it's south facing, or if there's any trees in the way for shading and things like that. Solar thermal, then, on the other hand, is 2 times more efficient than PV during the summer, but very inefficient during the winter time. They're very, very affordable. They're about 3,000 to 5,000 for a house, but they cannot provide 100% of your hot water. Usually it's only as a top up and to reduce the amount of heat that your boiler needs to get your hot water up and running. They have a very long lifespan with about nearly 30 to 40 years. They're very inefficient during the winter, though, as the heat in the winter time is non-existent, really. The evacuated tubes are the most efficient type of ones. They are very fragile, as they're a glass tube with a vacuum within it. So once you tap that glass or crack that glass, they're broken. There's no need for additional equipment. You just hook it straight into your hot water system to top it up. There are some techniques that you have to use to implement it correctly, but there's no need for things like inverters or transformers for it. There's flat panels are another type of solar thermal. They're very tough. They're literally a flat pane of glass with tubes running in between it, and they're very tough. They can withstand mostly anything. And again, one of the main things about solar panels is there's no noise pollution associated. And then finally, we'll move on to wind turbines or wind energy. Now, there are 2 types of wind turbines available in the market, which are horizontal axis wind turbines, which you probably see mainly everywhere for large wind farms. They're probably the most popular for large scale. And a 10 kilowatt turbine will cost you around 50 grand to buy. That's excluding the construction costs, which are very high for wind turbines with the amount of concrete that's required for the base. And then there's vertical axis wind turbines. There is a potential market, but they are very small scale. They're very small scale, as in like residential and micro generation application scale. They are smaller than their bigger horizontal brothers, but they are less noisy, and they can be used in higher wind speeds, as the vertical axis it also is part of the structure, so it can withstand higher winds. And just some tools available for wind. You can see there the SEI wind resource map. You can see there all the wind turbines that are actually wind farms that are currently in operation in Ireland. And you can also find out the wind speed here in the right map. So this is a wind speed at 150 meters high throughout Ireland. You can see the red dots there. They're mainly coastal areas with the winds being higher in coastal areas and in mountainous areas. Now you can find a resource pack at this website here. Now, I hope this module was insightful and helpful for you. For more training, please see Module 1, which introduces energy management principles and climate change. Module 2, which looks at behavioral change and the SPEEDIER app. And Module 3, that looks at transport. And then to come, which is Module 5 and 6.